Find the y-intercept, if any, x-intercepts, if any, vertical asymptotes, if any, including the asymptotic behavior on each side, and holes, if any, for f of x equals x minus 3 divided by x squared minus 5x. The first thing to find is the y-intercept. This is where the function crosses the y-axis, defined by x equals 0. The corresponding y-coordinate can be found by plugging 0 into the function for each of the x's. That will give 0 minus 3 divided by 0 squared minus 5 times 0. 0 minus 3 is a negative 3 over 0 squared is a 0 minus 5 times 0 is also a 0, giving negative 3 over 0. The 0 in the denominator is an actual 0 since this is not a limit, and 0 in the denominator is not allowed. Therefore, there is none. For the remaining parts, we will want to take the function f of x, which is x minus 3 divided by x squared minus 5x, and fully factor the numerator and denominator. The numerator does not factor. The denominator has a common factor of x. And then cancel out any common factors in the numerator and denominator. There is none that are matching. After all that's done, the x-intercepts, which correspond to y equals 0, this is where it crosses the x-axis, can be found by taking the leftover numerator and setting it equal to 0. Setting that equal to 0 and solving for x gives x equals 3. So the x-coordinate is 3, the corresponding y-coordinate is 0. And there's the x-intercept. The vertical asymptotes are found by taking the remaining denominator, setting it equal to 0, and solving for each of those x's. That will give x equals 0, and x equals 5. We want to look at the asymptotic behavior on each side of the 0 and the 5. This is done by taking the limit as x approaches from the left side and right side. The left side of 0, indicated by the negative superscript on 0, of the factored version of the function. And the right side indicated by the positive superscript on the 0, again of the factored version of the function. Let's start with the left side of limit. The left side of 0 is negative numbers. Plugged in for the factor that's making 0 in the denominator as x approaches 0, which is the x. Plugging in for that will give a negative number. So x will be a negative number, though it does approach a 0. So x can be replaced with a negative 0. 0 can then plug in for all remaining x's. So this will be a negative 0, and we can plug 0 in for all remaining x's. 0 minus 3 is a negative 3, divided by a negative 0 times 0 minus 5 is a negative 5. Giving negative 3 divided by negative times negative is positive, 0 times 5 is 0. A negative over a positive is negative, non-zero over 0 is an infinity. And there's the asymptotic behavior on the left side of the x equals 0 vertical asymptote. Now for the right side. The right side of 0 is positive numbers, plugged in for the factor that's making 0 in the denominator. It will be a positive number, though it does approach to 0, so that can be replaced with a positive 0. 0 can then plug in for all remaining x's. 0 minus 3 is a negative 3, divided by a positive 0. 0 minus 5 is a negative 5, giving a negative 3 divided by positive times negative is negative, 0 times 5 is 0. A negative over a negative is positive, non-zero over 0 is an infinity. And there's the asymptotic behavior on the right side of the x equals 0 vertical asymptote. X equals 5, we can look at the left side limit, indicated by the negative superscript on the 5, of the factored version of the function. And the Right-sided limit indicated by the positive superscript on the 5 of the factored version of the function. Let's start with the left-sided limit. The left side of 5 means less positive than 5, like 4.99. If plugged in for the factor in the denominator that's making the 0, which is the x minus 5, 4.99 minus 5 is a negative number. It will be approaching 0, but it will stay negative. Let's replace x minus 5 with a negative 0. 5 can then plug in for all remaining x's, giving 5 minus 3 divided by 5 times x minus 5 is a negative 0. 5 minus 3 is a 2, divided by 5 times a negative 0 will be a negative 0. The numerator is a positive 2. A positive over a negative is negative. Non-zero over 0 is an infinity. And there's the asymptotic behavior on the left side of the x equals 5 vertical asymptote. Now we can analyze the right side of 5, which will be similar. Right side of 5 is more positive than 5, like 5.01. If plugged in for x in the factor that's making 0 in the denominator, the x minus 5, 5.01 minus 5 is positive. But it will be approaching to 0 while remaining positive, so x minus 5 can be replaced with a positive 0. 5 can then plug in for all remaining x's, giving 5 minus 3 divided by 5 times a positive 0. 5 minus 3 is a 2. 5 times a positive 0 remain positive and will be a 0. The numerator is a positive 2. Positive over positive is positive. Non-zero over 0 is an infinity. And there's the asymptotic behavior on the right side of the x equals 5 vertical asymptote. The last thing to determine are the holes in the graph. Holes occur when there is factors in the numerator and denominator of the function that cancel with each other so that all of them in the denominator fully cancel out. We didn't have any factors cancel here, so there are none.